Hi guys, welcome back. This is the second part of the chapter, and this lesson is based on precipitation, also known as the solids that are formed. The objective for this part is for you guys to be able to determine when a precipitate forms when solutions are combined by following solubility rules as expressed by net ionic equations. In other words, after this lesson, are you able to determine when a solid forms, a precipitate forms, when solutions are combined by following solubility rules? And also, are you able to write net ionic equations? A precipitation reaction is a reaction in a solution that results in an insoluble product. That insoluble product is an item that, or a compound that does not dissolve, so it stays as a solid. And you'll know it's a solid in a written chemical equation if it has the lowercase s surrounded by the parentheses. For example, here is a chemical reaction, barium chloride plus sodium sulfate, which produces barium sulfate and also sodium chloride. Of all of these compounds here, which one is the precipitate? If you guess barium sulfate, then you are correct because it's got that small s there. That tells you that is the solid, the precipitate that has formed. Sodium chloride here is still able to dissolve, table salt, it can dissolve in water. And you see that it is still in an aqueous solution form. Now let's take a look at what it actually happens when you mix those two together, the barium chloride and the sodium sulfate. I hope you guys will be able to see this from this recording. Let's turn up the volume.
When aqueous barium chloride is added to a solution of sodium sulfate, a white precipitate of barium sulfate is formed.
All right, you see all that? Never mind the ad. You see all of that white stuff there? That is the insoluble solid, the barium chloride. And oh my gosh, you all don't need to look at my history in YouTube. All right, so let's take a look. Now, the important question, one of the important questions here, how can we predict when a precipitation occurs in a reaction? How we can do it? By looking at this table, the solubility rules, another super duper important and useful tool in chemistry that you can use. If you look on the left side over here, the top box, soluble compounds, the compounds that can dissolve and won't form a precipitate, include these ions. The anions are all of these guys here, and the cations. So if there is a compound that has these ions as a part of the compound, then you'll know it can dissolve. The exceptions are the bottom ones here. If you mix these positive ions with these negative ions, if you happen to mix them together, these combinations, they become insoluble precipitates. And let's take a look. Let me see if I can write on this. Okay. For example, if you mix silver with chloride, you mix those two together, it'll form silver chloride, which is insoluble. If you mix silver with this one here, bromine, silver bromide, that's also insoluble. Also silver iodide, that's the other one here. And the other combination that's also insoluble will be mercury 2. So it'll be mercury 2, mercury 2 chloride, that's insoluble. Mercury 2 bromide, that is also insoluble, so on and so forth. So any of these combinations here, silver, mercury, lead, these three combined with these three, All of those combinations will make a precipitate. These are the only exceptions. And also we've got more exceptions here. Again, silver, calcium, strontium, barium, and lead. If all of these were mixed with the sulfate, it's also an insoluble precipitate. Now, the other side over here, these are the ones that are insoluble. Okay, so we got carbonate, phosphate, chromate, sulfur, and hydroxide, sulfide and hydroxide. If you see these guys, they are generally not soluble and will form a precipitate. Now, when these guys are mixed with some ions such as lithium, sodium, potassium, rubidium, and ammonia, okay, if you mix those with these ions, then that's the exception. They become soluble. For example, we mix sodium with carbonate, sodium carbonate. That will actually dissociate and dissolve. Mix lithium with phosphate, that can dissolve. So these guys here, lithium, sodium, potassium, rubidium, and ammonia, will actually make them soluble. Okay? And also, same guys, with hydroxide, that can also make them soluble. These are the exceptions of when these items that are normally insoluble, when mixed in a combination of these ions, that's when they become soluble. Okay, so that is a lot of information. So I do not want you guys to memorize these combinations. Rather, we will use this table as our tool to decide which ones turn into precipitates, turns into solids, and which ones can dissolve. Okay, now what we want to do is to break up the chemical reactions into ions. All right, if we break up the compounds into ions, if we write the equation all in ions, we actually get a better idea of what is happening, okay? And then we consult the solubility rules to see which compounds, when we mix them up together, put them in different combinations, which ones are soluble and which ones are insoluble. And if the compound turns out to be insoluble, that's your solid. And we don't have to break that up. We don't separate that compound into ions. So remember, if the compound is insoluble, it's the precipitate, and we don't separate that into ions. Now, let's break up the chemical reaction, this chemical reaction here. And I like writing on this annotator better than actually the PowerPoint. I have more control with my writing here. Okay, so let's break up this chemical equation into ions. Let's do this in red. So let's break up the barium chloride into ions. Barium and chloride. Oh, okay, yes, I'll save it to drive. Goodness. Let's close it. Thank you. Okay, so barium is the positive ion. And how do I know what the oxidation state is? Well, either I can look it up on the periodic table or just simply look at the subscript here. So the subscript down here with the crisscross method, the subscript is a 2 down there with the chloride, so therefore the positive here is actually 2, okay? And there's only one barium there. So now we have the chloride ion. Chloride is the negative ion, okay? And doing the crisscross method, we see that there is no subscript for the barium, so that's why we keep that as just one negative, okay? And this is aqueous, so don't forget to also write down the AQ right there. Okay, now the next one, this is aqueous. We can break this up into sodium and sulfate. Remember, this is a polyatomic ion, all right? SO4 just by itself. Sodium is in the first column of the periodic table, so we already know that it has a 1 positive charge. And also, if you forget, Look at the subscript down there, not including the 4. Remember, this is a polyatomic ion, SO4 together, so it's a 1 down there. It's not, it doesn't say that it's a 1, but remember, we don't put down a 1 because it is redundant. Okay, so the charge is a positive 1 for sodium. And we see that sodium, there's 2 of them, so we gotta make sure that we put the 2 coefficient there because this tells you we have 2 sodiums. Okay, and then the sulfate anion, the polyatomic ion, write it all out, SO4. And to figure out the oxidation charge for the sulfate, we do the crisscross method, this entire thing over here, crisscross to the 2 there. We know that this is a -2 charge, all right? Again, don't forget this is aqueous, and this is also aqueous. Do the yield arrow. Barium sulfate, oh, take a look. This is a precipitate, so we don't have to separate this. Leave that as is. BaSO4, okay? And then the next one, sodium chloride, it's aqueous, so we can separate that. We can break that apart into 2 ions. Sodium, and we know the oxidation state is +1. Oh, but look, we've got 2 sodiums here. Don't forget to put the coefficient. And also aqueous. And the chloride is in the 17th column, so the oxidation state is a -1. But also don't forget, there is a 2 in front of this compound, and there's a total of 2 chloride ions, and also aqueous. And that's how you break apart this chemical equation, okay? Okay, now the next part here, spectator ions, those are the same ions formed on both sides. So we got to get rid of them if we see the exact same ions on both sides. Take a look over here. We have barium on this side here. Do we see a barium ion on the right side? No, we don't. So we leave that alone. We have a chloride ion here, and look, I forgot to put the 2 in front of there. I forgot that there are 2 chlorides there. Okay, so that makes it better. 2 chloride ions. Is there a 2 chloride ion on the other side? Yes, there is. So what we can do, we can cancel them out. Do we have 2 sodium ions on this side and the other side? Yes. Exactly the same, so we can cancel them out. Sulfate ion on this side. Is there a sulfate ion? Nope, not by itself. So all that's left will be the net ionic equation. So all that's left after you cross everything out is the net ionic equation. So you rewrite this as barium, aqueous, plus SO4, also aqueous. And the result is barium sulfate. And that is the precipitate, the solid that forms. This is your net ionic equation. Okay, let's go back to my PowerPoint right here. Oopsie, not that one. All right, and after you crossed out the spectator ions, you should have gotten your net ionic equation as demonstrated by that worksheet. So what I want you guys to do is to do this problem on your own. When a solution of lead nitrate is added to a solution of sodium iodide, a reaction occurs to produce lead iodide and sodium nitrate. Write the chemical equation, balance it, identify any insoluble products. So is this a precipitation reaction or not? Also write the net ionic equation. Once you finish this, there is one last problem where you will determine if each component of this chemical reaction is aqueous solution or the solid precipitate. And please come to my live session so that you can check to see if you got your answers correctly. And after this, for this chapter, were you able to compare and contrast the three acid-base theories, determine when a precipitate forms, and write net ionic equations?